Hello everyone, welcome to my channel Coding Together. My name is Vikas Oja. Today we will see another Leetcode problem, that is validate binary search tree. It's a medium complexity problem and it's also a very popular problem, as you can see from the likes. So let's read the problem statement, that we are given with a root of a binary tree and we have to validate whether it's a valid binary search tree or not. So the properties of a valid BST are that the left subtree of a node contains only nodes with keys less than nodes key, right? So the left part should be less than the nodes key, right? Like this, if one is less than 2, so it's okay. Now the right subtree also should contain the nodes with key greater than the nodes key. All the right subtree of a node must be greater than the nodes key, right? So if you see this example, if on the root node is 2, so the node key is 2 and the left subtree has only one element, although, but if there are more descendants on the left side, so the whole subtree must be less than 2, and on the right side the values should be greater than 2. And third point, both the left tree and the right subtrees must be binary search trees. So recursively at each level the same should follow, the 1 and 2 points must follow. So if you see this example, so if you can see, we have started with root node as 5. On the left we have 1, right? So on the left subtree we have 1 and elements are smaller than 5, so it's okay. And it was only one descendant 1, so and it is smaller than 5. Now on the right side we have 4, 6, 3. So 6, as you can see, is greater than 5. 3 and 4 are smaller, so they are not allowed on the right side of the 5, because for a valid BST the numbers on the right subtree of 5 should be greater. So this is not a valid BST. So let's see the problem with the same example that we saw. We'll do the tree traversal. That is DFS pre-order, right? Starting from root node. So this is root node, and taking left. So we'll have two more variables. So variables as left and right, left and right. So why this left and right? What are these left and rights used for? Each node in a BST must be greater than left part and must be strictly greater and strictly smaller than right part. Okay? That's what we know. Because in a BST, as we are saying, what are the properties? That the node must be less than the subtrees. The left subtree of a node must be smaller than the nodes key, and the right subtree must be greater than the nodes key, right? So in turn the node should be smaller than the right value, right, its corresponding right value, and it should be greater than the left value. So we'll start from the root. Now we'll initialize our left as -infinity and right as infinity, right? These two initializations, right as infinity. Now we'll check the 5, the first root node, whether it's greater than whether it's smaller than right or not. Yes, 5 is smaller than infinity. And whether it's greater than left. Yes, it's greater than -infinity. So it's a valid node, right? It's a valid position. Now we will go on the left part, because in a pre-ordered traversal what we do is root, then left, and then right. This is the pre-ordered traversal. So we have done our root. Now we'll go on left. So on left, whenever we will go left, so now for the node 1, what is the right of the node 1 is 5. So right will change, for 1 right will become 5. Now right will become 5 and left will be same as infinity, right? So whenever we will go left, we'll update our right will be updated, right will be updated, right? Whenever we traverse left, right will be updated. Whenever we traverse right, left will be updated, left will be updated. So from 5, when we went to 1, our right became 5, the previous element, right, or the parent element of 1, that is 5. So we changed infinity to 5 and the left remaining minus infinity. Now we'll check 1 again, right? We'll check 1 again, whether 1 should be greater than left and should be smaller than right. So what are we checking at each node? That the value of node must be smaller than right and should be greater than left. That's the only thing we are checking, and that's the only thing that validates a BST. That is the condition of BST, right? That is the condition of BST. So for this, 1 should be smaller than 5, that is, yes, it is smaller than 5, and it is greater than minus infinity, yes, it's greater than infinity. So what we will return? We will return true. We will return true because there is no elements further, so we'll return 2 from here. So now we are done with the left part. Now we have to traverse the right as a pre-order, so we'll go on right, that is to 4. Now again we are going from going on the right. So whenever we traverse right, what is the variable that will be updated? The left will be updated. So what we will do, so left will become 5 and right will be infinity, right? Because at this 5, right was infinity, left was minus infinity. When we went right, the left will become 5 and right will be infinity. So now again we'll check 4 is greater than left. No, it's not greater than left. It's not greater than left. So 4 is not greater than left. It's not greater than left. So it's not a valid BST. It's not a valid BST. Here only we are not seeing the things, right? Here only it's incorrect. This only condition is incorrect. So this, yeah, so here this condition is not matching, this condition not matching. So what we will do, we will not traverse further, this only condition is false, will return false, will return false. And from here, what is the AND condition? That is true and false, will return false, So now let's see another example with a slight change. I've changed some elements. Now we'll again do the same process. We'll start from the root. We'll have our left as minus infinity, right as equal to infinity. Now we'll compare 5. 5 is greater than left and is smaller than right. So we'll move left, right? Because we are following left pre-order. So root left and then right. So we are done with root. We go on left. So on left, so when we go left, right, so right will be updated. So at here for 1, left will be minus infinity and right will be 5, right? Just the previous element. So here 1 is greater than left and is smaller than 5, so it will return true. Now we are done with the left part, then we have to iterate right. So we'll go on left, right? We'll check here. So when we go on the right, our left will be updated. So for here, the left will be 5 and right will be infinity. So 8 is greater than 5, n is smaller than infinity, right? So then we will go again to the 7, so on the left part. So on 7 we again, when we go left, so our right will be updated, so left will be 5 and right will become 8. So 7 is greater than 5 and is smaller than 8, so it's right, it's a valid node, so we will return from here, returning true. Then we are done with the left part, we'll traverse right. So on right, whenever we go right, what is updated? Left is updated, so left will be 8 and right will be infinity. So 9 is greater than left and is smaller than infinity, so what we will return? We'll return true. So the true and true at 8, what is the AND of true and true? That is true, so we'll return true from 8. And from true and true, that is AND is true, right? So this is another example that represents a valid BST. So it's a valid BST. So simple iterating in a pre-order fashion, stopping at the leaf nodes, because at the leaf node we have null, right? The left and child descendants are null. We have to backtrack and going from left to root to left and then on the right side using pre-order fashion and updating left and right accordingly, then getting to know what is the valid BST or not. So let's see the code part of it. So simple code that first we have initialized our left as minimum value, long dot minimum value, and max value as long dot max value. And because the values can be large, so we have taken as a long. Now if root is equal to null, we'll return true, right? Means we have reached the leaf node, last node. Then if root dot val is greater than equal to right or root dot val is less than equal to left, right? If this condition is not meeting, right, the node value should be greater than left and should be smaller than right. So if this condition is not meeting, if the root dot value is greater than equal to right or root dot value is less than equal to right, we'll return false, right? It's a misplaced node or it's not a valid node for a BST. Otherwise we'll do the DFS on the left side, on the left subtree first, left subtree, and then on the right, so in a pre-order fashion. So first the root, then on the left part, and then on the right part, and then we take the AND of both. Let's run the test cases. So yeah, test cases are passing. So I hope you like this video. If you like this video, please share and subscribe. Thank you. Bye.